Part 3 of reading through the slides for Chapter 4 of Sommerville Software Engineering. So if you decide to go with specifications that are a bit more stilted, that can improve the clarity and the making it unambiguous. However, if you're writing business requirements, sometimes you need to be a bit more expressive. So it depends on the project you're working on, whether to use something that's highly structured. If you use form-based specifications, you want to define the function or entity, the inputs, the outputs, information about what computations needed, what's the action to be taken, what are the pre and post conditions, and what are the side effects. And here's an example for an insulin pump. I'm not going to go through that. It's a bit more detail for the insulin pump. Sometimes you want to put requirements in the form of a table. And this is usually to supplement the actual shall statements. You don't want to use a whole series of shall statements when it might be quicker to just show the numbers in a table. You would refer to the table, so you need to number the table. In fact, when you write requirements, all of the requirements should be numbered. And here's an example of the way you might specify things to do with numbers and ranges. Again, it's for the insulin pump example. We've already talked about use cases in class, and I hope you understand how they're going. I'll talk through these because there's a couple of interesting pieces, right? So here's our ment care system, and we've got 4 actors, and we've got, 7 use cases. I usually try to limit the number of use cases on a diagram to a maximum of about 9. Once it starts getting above 9, things start getting too complicated. This is about the right order of complexity that you want on a use case diagram. So you need to write a requirements document. It's all about the what, and should not rather say how it should be done. You want to give the designer, the software engineers, room to maneuver, room to be creative in the way they solve the problem. This is all about stating the problem rather than solving it. And these are all the different people who may use a requirements document. The system customers, the managers, the system engineers, the test engineers, and the maintenance engineers. All these people have some use for requirements. Requirements documents vary. Right? There's an IEEE standard that some people use. I'll see if I can get a hold of that. There are various other internal house standards that companies use. If you are in an environment that has a standard, use it. This is just walking through the sorts of things you might have in a requirements document, and you should be able to understand most of these. This is very similar to the system proposal. It's a little different. The system proposal out of Dennis Wixom and Teagarden is using a very specific standard. It's not the only thing you can do, and here's a slight variation on it. One thing that Sommerville here introduces or adds that maybe isn't explicitly pulled out in the Dennis Wixom and Teagarden template is the glossary. I'm a big fan of glossaries. I think particularly if it's an area that the development team doesn't know very well, it's worthwhile having a glossary to explain acronyms or terms of art that maybe they're not familiar with if they're not subject matter experts. So validation is making sure that the customer's going to get what they want. And we haven't built anything yet, so we have to only look at the requirements to see whether that's going to happen. And so it's requirements validation. And so we should look at that. So what do? You check that the requirements are valid. You check that they're consistent. You check that they're complete. You check that they're possible or real, reality based, and you check that they can be verified, right? The difference between verification and validation is verification is an objective check to see that a requirement is true. It's either true or it's not. It's either verified or it's not. Validation is checking that the customer gets what they want. And if something isn't validated, that possibly means that the requirement was never written down. Right? So it's not only a check of the system delivered, it's a check on the requirements written up front, which is why it's important to try and validate all requirements. Right, there's various ways of validating requirements. You can review them, get lots of people to review them. You can prototype, so based on the requirements, put together a mock-up and see that that works. Another pretty good way is now that you've got a requirements document, you can actually generate test cases for the system that's going to be built. And generating test cases, if you've got somebody who's experienced in quality assurance, then that can be a very good way to show up other inconsistencies with the requirements. You should review requirements regularly, right? You don't just set them in stone and that's it. The reviews should be formal or informal. A bit of both helps. You need to involve as many of the system participants as possible, both the client, the customer, and the development team working on it. Right, so there some of the review checks. Is the requirement testable? Is the requirement understood? Do we know where the requirement came from? This is what I think I've said a few times about traceability of the requirement. It's worthwhile being able to know why the requirement is there. And adaptability. Can the requirement be changed without a large impact on other requirements? If there is a requirement that, if changed, will change lots of other stuff, then your design may not be very robust. And the thing it's probably not robust against is change. And unfortunately, that's one constant in software engineering, is that things change. And one of the key pieces is the second top level point here. The people who pay for a system and the users of that system are not the same people. So you're playing to two different audiences often. And large systems have a very diverse user community, so they've got different requirements. There's a case where a bug was introduced into a system that I know, and a lot of customers found the bug but made use of it. And so when we proposed to fix the bug, they said, no, we use that. So we kept the bug and we documented it as a feature. Okay, requirements change. We have an initial understanding of the problem. We do the initial requirements. Once we've done the initial requirements, we probably change our understanding. So we may have to update the requirements. And this happens even when you're writing requirements, when you're doing object-oriented analysis with the use cases and the sequence diagrams and the state diagrams and the activity diagrams. But it also changes, your understanding changes as you start writing the code. So it is an evolutionary process. However, you can't just change things willy-nilly, right? You need to keep track of the requirements and how they change, and you should establish a formal process for changing those things or approving those changes. Right, and what's this saying? It establishes the level of requirements management detail that is required. And it depends on the actual requirement, how you do the requirements management. If it's a life safety issue, you need to be very, very sure when you change. If it's just to do with a color in the UI, maybe it's not as big a deal. One of the things you should do if you're proposing a change to the requirement is to analyze it and do an impact assessment, a change analysis, and a costing. Is it going to cost a lot more? Is it going to be cheaper? Having an idea of what the impact of the change is important. Right, and this is the thought process. You identify the problem, you analyze and change the specification, you analyze that change and cost it, you think about implementing the change, and that revises the requirements. So here are the key points, and you can read these as well as I can. Requirements set out what the system should do and how well it should do it. There's functional requirements, which is the do, and there's cross-functional requirements, which is how well. There's often emergent requirements as you start thinking about it. Requirements engineering is iterative. You can't just do one hit and it's done. You should use a range of things to find your requirements, not just think about it. You should talk to people. The requirement specification is formally writing stuff down, and the document is an agreed, in some ways, contract between the developers and the customers. We need to validate requirements before we get into development, and we need to be aware that we're going to have to change the requirements, so put a process in place to do that. Okay, that's the end of chapter 4 of Sommerville.